So let's start it. Good morning, everyone, and welcome to this class. This is alternating current lecture number 2. In the previous class, we had discussed what is alternating current or alternating voltage. Voltage that changes its direction with time is known as alternating current or alternating voltage. We've also seen something known as the average value, and the RMS value of voltage or current. Okay, not a problem. You can't hear me, but if there's any doubt, you can type. We had seen that the RMS value of anything is V0 by root 2 if it is voltage, or if it is current, it is I0 by root 2. We had seen that. We'd also seen that there is something known as phase or phase difference in AC. Current and voltage may not be in the same phase. If it is resistance, voltage across resistance and current across resistance are in same phase. I hope we remember that. Voltage and current in a resistor are in the same phase. Voltage across inductor leads the current across inductor by a phase angle of pi by 2 or 90 degrees. Current is lagging voltage by 90, or voltage is leading current by 90. Similarly, voltage across capacitor lags current across capacitor by a phase angle of pi by 2. We had also seen their Phasor diagram. We had seen that here the resistance of the circuit is R. In the case of a pure inductive circuit, we devised a term which was known as XL. This XL was equal to omega L. And this XL was known as inductive reactance. Similarly, I had XC, which was known as capacitive reactance, and the formula was 1 by omega C. Okay, sound will not be audible to us of viewers. You can't hear me? Don't write so complicated language. I get confused what you mean to say. Am I audible and visible to all of you? Just reply yes or no. You can see me, you can hear me. Can hear me, you can see me, yes or no. You can't hear me, right? Sir can't hear you. What you're writing does not make, it's not making any sense to me. I don't understand what you mean to say. Am I audible and visible to all of you? Okay, so I understand that you don't hear me, but I don't hear you, but you can hear me. So these three things we had already discussed. What we are going to do to start off this class is just solve a question so that we understand how questions are framed in this case, and I will give you this particular question, and I hope that you are able to solve it. Again, this question is not from your sheet, so you will have to solve it from here. And the question comes like this. I'll read out for you. An alternating voltage E, sometimes it is written as E, sometimes it is written as V, is 200 root 2 sine 100t. This V stands for volts. It's connected to 1 microfarad, that's the capacitance, through an AC emitter. That means it will read the RMS value. What will be the reading of the emitter? So basically, they are going to ask me what is the value of IRMS. What will be the value of IRMS? Now, if a question comes like this, how are you going to solve it? How are you going to solve it? That is the first thing that you need to understand. So what will I do here is, before going on to this, I will show you a sheet, and we have already discussed the various aspects of resistive circuit, capacitive circuit, and inductive circuit. What I'll do is, I have one table here, and I will show you that table, and from that table we will try to understand something. Okay, so the table comes here. The first column is for purely resistive circuit. The second one is for purely inductive circuit. And the third one is for purely capacitive circuit. Here you see a resistor R, and this is a voltage source, a AC voltage source. The value of the voltage is V is equal to V naught sine omega t. Here, everything is same. The only difference is, here we have inductor and here we have capacitor. I hope everyone understands that. Now, if voltage is like that, this is the supply voltage, point number 1. Point number 2, if you have to find out the current and voltage are in the same phase. So current will look like I is equal to I naught sine omega t, where I naught is the peak value of current. As you can see, both of these are in the same phase. Current and voltage both are in the same phase. It is a purely resistive circuit. Current and voltage are in the same phase. I hope everyone understands this. Now here, if you see, the equation of current is written as I is equal to I naught sine omega t minus pi by 2. That means here voltage leads current by pi by 2. Current is minus pi by 2, so it is behind. Voltage is V is equal to V naught sine omega t. Current is sine omega t minus pi by 2. Therefore, current is lagging and voltage is leading. I hope all of you see this. Yes or no? Can I have some raise? Okay, you can't raise your hands, but I hope you can understand this. So look in the third part, Voltage is V is equal to V naught sine omega t. Let me highlight it. Voltage is V is equal to V naught sine omega t. But current is sine omega t plus pi by 2. That means here voltage is behind. Voltage lags current by pi by 2. I hope this is clear to all of you in the class. The first 2 points are basically simple aspects, that is telling me how to find out or how to write current if voltage is given to you. But here, as you can see, bacha, there is one unknown factor which is I naught, I naught, I naught. How do I find the value of I naught? How do I find the value of I naught? That is the third question. How do I get the value of peak current? And the answer is right in front of your eyes. Peak current is V naught divided by R. V is I naught, peak current is V naught divided by R. Similarly, peak current here, I can write it as V naught divided by XL. This XL is nothing but inductive reactance. As you can see, the job that resistance R is doing here, the same job is done by XL in this equation. Here I have put the value of XL as omega L. So the value of I naught becomes V naught divided by XL, or V naught divided by omega L. As you can see, in the third case, this R or omega L is replaced by 1 by omega C, or I can write it as V naught multiplied by omega C, or I can also write it as V naught divided by XC. This XC is doing the same job as XL here or R here. This XC is known as capacitive reactance. I hope we understand point number 1, point number 2, and point number 3. You have already drawn these 3 graphs, these 3 circuits. I'll give you 1 minute to note these 3 things. Point number 4 we will discuss just now, but right now I just want you to note point number 1, point number 2, and point number 3. Point number 4 would be, if I know the value of I naught, so first to write point number 1, 2, and 3, I'll give you a minute to do this. Now let me go ahead and start with the same thing. In case of pure resistance, I had seen that the value of I naught is V naught by R. In case of pure inductance, I had seen the value of I naught is V naught divided by XL. I will not write omega L always, because omega L might confuses me. I always understand that this R is replaced by XL, and this is the easiest way for me to understand that R and XL are doing the same thing. If I have a capacitance C, the value of I naught becomes V naught divided by XC. The value of XC is 1 by omega C. I know that. You know that. But here, what you have to understand is R is replaced by XL and XL is replaced by XC. If you understand this, almost 90% of AC is done. Almost 90% of AC is done. Almost 90% of AC is done. This is number 1 way in which you can remember I naught. Now, People may ask you to find out the value of IRMS, which was the question that we discussed. And we'll come back to that question. Don't worry, we'll come back to that question. Don't worry, we'll come back to that question. Now, if you want to find out the value of IRMS, that will be equal to I naught divided by root 2. So we can write it as V naught divided by root 2R, because I naught is V naught by R. Again, V naught by root 2 is simply VRMS divided by R. So as you can see here, bacha, what has happened? Here you had V naught and I naught. Here you have IRMS and VRMS. So everything looks similar. If I naught is V naught by R, IRMS is VRMS by R. It's as simple as that. 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 If I talk about IRMS here is also equal to I naught by root 2. That is also equal to V naught by root 2. Now, R gets replaced by XL. R gets replaced by XL. And I again land up with the same equation. IRMS is VRMS divided by XL. I hope I am making sense here and I am not talking nonsense. Again, you see, not and not peak values. And here we have RMS and RMS. And as you can see, this R has been replaced by XL. Apart from that, everything remains same. Everything remains same. If I continue the same topic here, IRMS will be equal to I naught by root 2. I can't change it. That will become equal to V naught divided by root 2 divided by XL. No, XC. I again land up with the same. IRMS is VRMS divided by root 2. See, XL has been replaced by XC and rest of the things remain same. I hope all of you understand this. I'll give you a minute to note this down before moving any further. I hope you are noting it down in the same table that you have created. Remember, that table has not been sent to you, so you will have to remember this. Now, if you have written it down, then we'll move on to the problem. We'll solve the problem and then we will go back and see what is happening with the problem. How can you solve that problem? So we'll go back to that problem once you are done with this writing. And I hope you are now fast enough to write this. So I'll move on and I will go on to this example. Again, as you see, we have a voltage and we have to find the value of IRMS. This value is your E naught or V naught. This value is your omega. This is your capacitance C. You have to find out the reading of the emitter. So basically, you need to find out IRMS. I will give you a minute to think about this and tell me the answer. Take your time, no hurry. Well, I hope you have tried this question. Well, let's see how we need to solve it. So let us move on to the solution, and the solution is pretty simple. I think most of you would have cracked it. If you could not, well, just have a look. So we compare this equation with the standard equation V is equal to V naught sine omega t, and as we see, the value of V naught is 200 root 2 and the value of omega is 100. That you can say as the first step of a problem. Find out the value of E naught, find out the value of omega. We have found out by seeing the equation. Then this is equation number 2. This is a capacitive circuit. So I find out the value of Xc. I find out the value of Xc. The value of Xc is 1 by omega c. 1 divided by omega c. This is 1. This is omega. Capacitance is 1 microfarad. You must understand 1 microfarad is 10 raised to the power minus 6 farad. To divide them, simple math, you get the value of Xc, which is capacitive reactance, and the value will come in omega because capacitive reactance is doing the same work as resistance does in a resistor. So now I have the value of E naught and I have the value of Xc. I have to find the value of IRMS. I'll give you a minute to think about it. I know that now you know the answer. I know that you know the answer. You just need to simply solve it and tell me, sir, Astic sir, this is the answer, sir. Please have a look at the answer and tell us that it is the correct answer, sir. E naught is 200 root 2 and the value of Xc is 10 raised to the power 4 ohms. What is the value of I naught or what is the value of IRMS? And the answer comes here. So I have to find out the value of IRMS, bacha. What do I do? ERMS divided by XC, divided by XC. Yes, divided by XC. E naught divided by root 2 will give me, this entire thing will give me, the value of ERMS. Because ERMS, as you know, as we all of us know, that ERMS is E naught divided by root 2, 200 divided by root 2, divided by root 2. So again, something wrong. Everything getting highlighted. 200 root 2 divided by root 2. Root 2 cancels. Again, problem. What is the problem here? I don't understand. Okay, I'll use a simple highlighter, not a highlighter. 200 root 2 divided by root 2 gets cancelled, and your answer is IRMS value is 20 milliamp. Do we understand this? You can't raise your hands. I'll wait for your reply. You can just reply by yes or no. If there's any doubt, please let me know. I'll wait for a minute. Well, I hope you have understood this. I have faith that you have understood this. I will now move along to the next question, and the next question is just a small part of this question that we have discussed. We have a capacitor of 50 picofarad. Picofarad is 10 raised to the power minus 12. It is connected to an AC source. Frequency of that AC source is 1 kilohertz. You have to find out the capacitive reactance. You have to find out the capacitive reactance, and I'll give you a minute to win it. A minute to win it. A minute to win it. Are we there, bacha? Are we there? Are we there? A capacitor of 50 microfarad capacitance is connected to a AC source. The frequency of that AC source is 1 kilohertz. Can you tell me what is its reactance? XC. They're asking us the value of XC. Can you help me out in finding out the value of XC? XC. What will be the answer, bacha? Please tell me. What will be the answer here? How do I get the value of XC? How will I get the value of XC? Sorry. How will I get the value of XC? Well, we know that XC is 1 by omega C. We have discussed this. We are not given omega here. We are given frequency 1 kilohertz. Omega, if you remember, is 2 pi f, 2 pi multiplied by the frequency f. So I multiplied by 2 pi. I multiplied by 2 pi. Then I multiplied by the capacitance. Pico means 10 raised to the power of minus 12. We do simple calculation. We do simple calculation in powers, and you get the answer as 10 raised to the power 7 divided by pi. That is the capacitive reactance of this. How I have done this, I will again repeat it. I have found out the value of omega. Omega is 2 pi into f. Multiplied it by the capacitance. Find out 1 divided by omega c, and that is my capacitive reactance. I hope all of you understand this. I hope all of you understand this. Yes or no? Yes or no? Please let me know. Yes or no? I hope all of you have understood this. I hope all of you understood this. Shall I move along? We have done 1 or 2 problems on XC. Now let us try and do one problem on XL. And this is the problem. The problem can be asked in a different way. In the given circuit, the applied voltage is V is equal to this thing, and the emitter reading is 2 amps. Okay. Our question is asked in a different way. Voltage V is given, and emitter reading, this is the emitter, AC emitter. The emitter reading is given. Can you help me in finding out the value of L? L stands for the inductance of this coil or the inductor. Your time starts now. I hope you have done this problem. V is given. We know the value of V naught. From there, you can find the value of VRMS. VRMS is V naught divided by root. You know the value of IRMS. From there, you can find out XL. If you know the value of XL, you should be able to find the value of L. I've given you the hint. V naught is known. Step number 1. Omega is known. Step number 2. Find out the value of VRMS. Step number 3. Then find the value of IRMS is given. Find the value of XL. Then find the value of L. It'll give you a minute to think about it again. Well, I hope you have solved this question. How do you solve this question? VRMS is IRMS multiplied by XL. Reading of the emitter. Emitter always gives you the RMS value. We have discussed that. We can write XL as VRMS divided by IRMS. VRMS is V naught divided by root 2. Root 2 gets cancelled. So it is 50 divided by IRMS. IRMS is 2. So my XL comes as 25 ohms. 50 divided by 2. Now this XL is equal to omega L. So my L will be XL divided by omega. Omega is 100 pi. Omega is 100 pi. So I divide 25 by 100 pi and I get the value of L as 1 by 4 pi. Do we understand this? You cannot raise your hands. I always raise my hands. I hope you understand this. I'll give you a minute to note this down. Well, I hope you have noted this down. It's time for me to move ahead in life. And so I move ahead. The next heading that we are going to write is impedance. The next study that we are going to write is impedance, denoted by the legendary letter Z. Now, what is this impedance? If I have a resistor in AC circuit, it has a resistance R. Resistor has a resistance in AC circuit, and that resistance is R. If I have an inductor in the circuit, bacha, AC circuit I am talking about, the resistance of that inductor is not known as resistance, it is known as inductive reactance. It is known as inductive reactance, and it is found out by finding out XL, and this XL is equal to omega L. Seen that? If I have a capacitor in the circuit, it has capacitive reactance. It has capacitive reactance. I call it by XC, and I find it by 1 by omega C. So far, so good. The thing is, here we are using, for resistor, we are using resistance. For inductor, we are using inductive reactance. And for capacitor, we are using the term capacitive reactance. If you can see, all these three things basically mean the same. They are doing the same job, but they have different names. Now, if I want to give them just one name in an AC circuit, if I want to give them just one name, what is that name that I can call them with? And that name is your impedance Z. So, this resistance R is the impedance. You can call this resistance as the impedance. You can call this XL as the impedance, and you can call this XC also as impedance. So simply, instead of using the word resistance or capacitive reactance or inductive reactance, I can simply call it impedance of the circuit. Because up till now, we only have, mark my words, up till now, we only have a resistor in the circuit, or we have an inductor in the circuit, or we have a capacitor in the circuit. But in the next class tomorrow, you will have a combination. You will have a RL circuit, you will have a RC circuit, you will have a LC circuit, you will also have LRC circuit. Now, when you have a combination of any two or three, you cannot call it resistance, or you cannot call it inductive reactance. You cannot call it capacitive reactance. You have to call it by one common name, and this one common name becomes your impedance. So impedance of the circuit, of an AC circuit, is basically the same thing as the resistance, but since it can have more than one element, I cannot call it resistance, so I call it impedance. I hope this is making sense. Now, once I call it impedance, in all these three circuits, I can write I naught as V naught divided by Z. In all these three circuits, I can write this I naught as V naught divided by C. The only difference is, in case of a resistor, this Z becomes R. In case of a inductor, this Z becomes XL. In case of a capacitor, this Z becomes XC. In the cases that are going to come tomorrow, It could be a combination of L and R. Again, I naught will be equal to V naught by Z. It can be a combination of R and C, but again, I naught will be V naught divided by Z. It can be a combination of L and C, but still I naught will be equal to V naught by Z. The only thing that will change is the value of Z. In different conditions, the value of Z would be different. For example, in case number 1, value of Z is R. In case number 2, the value of Z is omega L. In case number 3, this was case number 1. This is case number 2. And this is case number 3. Then there will be case number 4, where the value of Z will be different. Case number 5, where the value of Z will be different. Case number 6, where the value of Z will be different. And case number 7, where the value of Z would be different. Do we understand this? I hope all of you understand this since you cannot speak. Similarly, I can write VRMS as, IRMS as VRMS divided by Z. This Z can have different values. It can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, depending on how I have connected the value, how I have connected the resistance and the inductance and the capacitance. The value of Z will keep on changing. I will give you a minute to write it. A minute to write it, bacha. A minute to write it. A minute. I hope you have noted this. What is impedance? Now you go back to our table of R, L, and C. First column, as you know, is R. The second column, this is not the first column. The first column, is R. The second column, is L. And the third column, is C, capacitance. We have seen the value of peak current and we have seen the value of RMS current in terms of R, XL, and XC. Now, impedance Z. So you can write this impedance Z as V naught by I naught. Here, this impedance Z is XL. This becomes V naught by I naught. Same thing. Here, the impedance is XC. It becomes V naught divided by I naught. So here, in all the cases, impedance is different, but we can find it out from the same formula. Either it is V naught divided by I naught, V naught divided by I naught, or V RMS divided by RMS. I hope everyone agrees with me. Phase difference in resistance, phase difference is 0. In inductance, voltage leads current by pi by 2. In capacitance, voltage lags current by pi by 2. We already know this. We already seen the phasor diagram. Same phase. Voltage ahead by 90. Voltage lagging by 90. I will give you a minute to note this down. Well, I hope you have noted this down. I move on to the next point. And it's a very important diagram that has come many times in your exam, and that is why you are going to draw it. Variation of impedance with frequency. Resistance R, pure resistor circuit. The impedance is equal to R. R is independent of frequency, and hence this graph is a straight line. R does not depend on F. In case of a purely inductive circuit, your Z will be equal to XL. XL is omega L. Omega is 2 pi F. It is directly proportional and hence it is a straight line because Z or XL is directly proportional to F. In case of a purely capacitive circuit, if I draw the graph between F and XC or Z, XC or Z is inversely proportional and hence the graph is like this. Do we understand this? Now, here, if I do the inverse of resistance, I will get conductance. If I do inverse of, you are not going to be asked, inverse of inductive reactance, we get inductive susceptance. If you do inverse of capacitive reactance, we get capacitive susceptance. Remember, resistance behaves same in AC and DC. Inductance lets DC pass easily, but capacitance, it blocks DC current. You should never forget it. Resistance behaves the same way. Inductance allows DC to flow very easily, but capacitance always blocks DC current. This is one thing that you should never forget. One thing that you should never forget. And the last point is the Ohm's law for these V is equal to IR, V is equal to I into XL, V is equal to I into XC. If you remember these things, remember this R is equal to Z here, this XL is equal to Z here, this XC is equal to Z here. If you remember these things, more than 80-90% of AC would be solved. I leave you at this screen. The class is over. I hope tomorrow I would be able to hear you out, and we'll try to wind off AC in the next class, or maybe the next to next class. We'll solve some questions, and that is it from my end. I hope you have enjoyed the class. May not be so interactive, but we'll have to live with it. Take care and have a nice day. I'll see you tomorrow. If you have any doubts, you can stop. You can ask me.